Greetings, calculus students. Today we begin chapter 4, more derivatives. We're going to learn more derivative rules in this chapter, and by the end of this chapter you will be ready to take your derivers test. There's several more functions that we have to learn how to differentiate. Those include exponential, logarithmic functions. That's actually what we'll do at the very end of this chapter. We're also going to learn how to differentiate the inverse trig functions. But we're going to begin with a rule today that is so fundamental to so many different things and so many different functions. It's going to open up so many doors for us to be able to differentiate new kinds of functions and new, functions that just look a little bit different. So today we're going to be talking about, and this is in section 4.1, the chain rule. Okay, so we're going to start with defining the chain rule. And again, I'll put all of these notes on Google Classroom as well. But if f is differentiable at u equals g of x, and g is differentiable at x, then f of g of x, which can also be written as this, f of g of x. You'll remember or recall from Algebra 2 that this is a composition of functions. Today we're going to differentiate compositions of functions. You talked about f of g of x in Algebra 2. You're taking one function and plugging it into an entirely different function. So if f is differentiable at u equals g of x, and g is differentiable at x, then f of g of x, which is all written in either one of those notations, is differentiable at x, and f of g prime of x, meaning the derivative of this composition, is equal to f prime of g of x times g prime of x. F prime of g of x, that's g of x plugged into the derivative of f. Finally, we multiply by the derivative of g. So the real key here with this, and the part that's the trickiest sometimes with these kinds of functions, is determining which function is g and which function's f. G is the inside function because it's plugged into, g of x is plugged into f based on that notation for f of g of x. You have to know the derivative of the inside, or you have to know how to determine the inside function and then determine which function is the outside function. Because the chain rule, I take the derivative of the outside with g, the inside still plugged in, times the derivative of the inside. This is the chain, the g prime of x on the end right here. Okay, we'll even talk about later on if I have a function inside of a function inside of another function. If I do a nested function like that, I've got, multiple levels there. How to handle that. That just is going to add more chains onto the end. All right. This is all in Lagrange notation, so we also want to talk about in Leibniz notation. This rule basically says if y is equal to f of u and u is equal to g of x, then dy dx is going to equal dy du times du dx. Basically what we're doing is for the derivative of y with respect to x, we're going to derive y with respect to u because that u is the inside function. U has been plugged into there. So we're going to differentiate y with respect to u times the derivative of u with respect to x finally. So we differentiate the outside or the inside function on the end right here at the end, just like we did here with g. G was the inside function and we differentiated it at the end right there. So u is the g now. Okay? It just depends on how the problem is written, on which notation would be best to look at here. You really can use either, though. It just depends. Which sometimes one makes a little more sense. All right. So the trick is finding out which function's inside and which function's outside. So let's practice just a little bit with doing that. So let's move over here. So let's just say we want to know which function is the inside function and which function is the outside function. And those are not really math terms, inside and outside, technically. So I'm gonna put quotation marks around those because that's just my terms. Mr. Crabtree's terms, Adam Crabtree's terms, theirs. Okay, so which is the inside function and which function is the outside function? So let's just look at some examples. Let's start with an obvious one. Let's take y equals the square root of 3x squared plus 4x minus 5. And we might actually differentiate these in a minute on the next example. But right now I just want to know which one's the inside function and which one is the outside function. So I'm going to start with an easier one here. So we need to know which function's on the inside, which function's on the outside. So we look at this function, you can see that it's got, that looks like a polynomial right here, 3x squared plus 4x minus 5. That looks like a polynomial, but it's all underneath a square root function. So the inside function, okay, which will be our g of x, that's going to be the 3x squared plus 4x minus 5. That's on the inside of that square root function. So our inside function is the g of x equals 3x squared plus 4x minus 5. Our outside function, that's going to be our f of x. That's being plugged into a square root function, so the outside function will be the square root of x. Okay? Which we could even think of as x to the 1/2 power. So that we could power rule that if we wanted to take the derivative of it. Okay, so that's an example inside outside. So let's look at a different one. This one's tricky. Sine squared x. It doesn't look too complicated. Oh, I didn't label it, sorry. Instead of that, let's put y equals sine squared x. All right, doesn't look too complicated. Y equals the sine squared x. It's not a too complicated function. So the hard part here is determining inside and outside. And this is tricky with trig functions with powers on them. Okay, you almost just have to kind of learn the pattern here with these. So if we want to know the inside function and we want to know the outside function, inside functions g of x, outside functions f of x. So the inside function, this one's tricky because you look at it just by the order of the way that they write it, it looks like the sine function's on the outside and the squared's on the inside. But if you think about, you have to think about this intuitively just a little bit, okay? Really, this is sine of x squared. This is sine of x times sine of x. It's the sine x function being squared. So really, the inside function for this one is sine of x. And it's being plugged into a squared function like x squared. If I were to plug sine of x into x squared, I get sine squared x. Okay? You're taking this function g and plugging it into f. Okay, we're thinking ahead to what the notation, f of g of x. Think back to that, what we were just talking about. If we plug sine of x into this x squared function, we get sine squared x. Okay? With powers on trig functions, the trig function will be your inside function. Okay? The outside function would be the power function. Okay? All right? We can do other examples like absolute value of something, which really you wouldn't want to do that because we know the absolute value function, we don't have a derivative rule for that. But we could do it with a cubic function. We could plug we can even do it with a function that we can even do something like this where we have like y equals x squared plus 3x minus 7 quantity cubed. I don't know about you, but I do not want to have to go in there and actually write that out 3 times, do all the distributing and all this algebra to get down to a big old long polynomial, okay, that's going to be of the 6th degree. I can tell you that because if we got a squared function inside of a cube function, if I do 2x squared to the 3rd power, I'm going to get a x to the 6th. So it's going to be a 6th degree polynomial. It's potentially going to have every term. So it could potentially have a 5th degree term, a 4th degree term, a 3rd degree term, a 2nd degree term, a 1st degree term. You have all kinds of common like terms to combine there to get to that. That's going to be complicated. Instead, you can think about it in terms of f of g of x. Pick your inside, pick your outside function. The inside function forgive me, I'm not going to write function, but the inside function would be that inside part, x squared plus 3x minus 7. The outside function whoops, got my f's and g's mixed up. My outside function, which is f, would be that cubic function, x cubed. If I take x squared plus 3x minus 7 and I plug it into the x cubed function, I get this function right here. If you replace x in the cubic function with x squared plus 3x minus 7, you get this function y. Okay? So it can be a little tricky sometimes with the outside function to kind of determine what that function looks like, but it's usually the square, it's usually a pretty basic parent function. Okay, not always, but a lot of times it does end up being a basic parent function. All right, so we can use this now to help us derive these. Okay, so we're going to move over here to just to the right, and I'm going to find the derivatives of these functions. Find the derivatives of the 3 functions in the previous example. Again, I'll put all of these notes, I'll put a PDF or picture of these notes on Google Classroom as well. So for the first one, we had y equals the square root of 3x squared plus 4x minus 5. So we know what our g is. G of x, the inside function, was 3x squared plus 4x minus 5. We know what our f is. That's the square root of x. And we know the chain rule. The chain rule says that I'm going to find f prime of g of x times g prime of x. That's from our chain rule definition earlier in our notes. So I'm going to find the derivative of f with g still plugged in. I'm going to plug g into the derivative of f. So I'm going to take and find the derivative of f. Okay, so let's just go ahead and find the derivative of f. F prime of x, we think of that as x to the 1/2. That's going to be 1/2 x to the negative 1/2, which is 1/2 or 1 over 2 x to the positive 1/2, which is 1 over 2 square root of x. Okay. Sorry, I got kind of low on the board. Let me rewrite that. I'll make it a little better. Let me move everything around a little bit. Sorry. So we get our derivative of our square root function to be 1 over 2 square root of x. That one doesn't really have its own rule. I've not defined it as its own rule, but it honestly deserves to be its own rule. I have in the past actually defined it its own rule, but I forgot to do that with you all. So we may define that as a rule. The square root of x function is going to be that. We can do that after this, actually. It'll make it a little easier after we do this. All right, so then we'll need the derivative of g here in a minute anyway, so let's just go ahead and find the derivative of g. That's going to be 6x plus 4. Okay, so then I take the chain rule, f prime of g of x times g prime of x. So f prime is 1 over 2 square root of x, but I'm going to plug g into that. So I'm going to get 1 over 2 times the square root of 3x squared plus 4x minus 5. That's 1 over 2 square root of x. That's f prime, but with g plugged into it. G of x is the 3x squared plus 4x minus 5. So I'm plugging that into for x and 1 over 2 square root of x. So I get this. Times the derivative of g. That's 6x plus 4. And the only way we can clean this up, well, 1, we can multiply across here. 1 times all that's just going to be 6x plus 4. So our final answer will be 6x plus 4 divided by 2 square root of 3x squared plus 4x minus 5. And technically, this is divisible by 2, this is divisible by 2, this is divisible by 2, so you can simplify that to 3x plus 2 all over the square root of 3x squared plus 4x minus 5. Okay, that little technicality there, that little cleaning up right there doesn't always happen, but it does here. So you can technically write that as 3x plus 2 all over the square root of 3x squared plus 4x minus 5. And that's our answer for part A. Okay. That's the derivative of that function. Okay. So let's apply the chain rule with the other ones. These won't take as long. Eh.